Hello guys, hello world, hello Philippines. As I promised, the whole month of September will also be intended to chemistry topics, vloggings and live streamings. So I'm done with the gases, ideal gas law, and the real gases. Okay, principles, formulas, okay, and including the problem solving. Okay, now let's shift to another topic. I must remove this mask so that I can talk properly. Hello, guys. It's very clear now. Okay, by the way, I will remove my helmet. Okay, so that I can convey the message to everybody directly. Okay, so our topic for this quick, shall I say quick, vlogging is all about stoichiometry. Okay, so I think this subject is not common in other courses. Okay, but if you talk up engineering courses, specifically BS Chemical Engineering or BS Chemistry, so this topic is very popular. Okay, stoichiometry is similar as chemical calculations. So, if we talk about stoichiometry, it should be understood that there are calculations involved. Okay, calculations of the reactants and the products in the chemical reaction. Again, calculation of the reactants and the products in the chemical reaction. Thus, if we say like that, we should always refer to the law of conservation of mass, if you remember that in chemistry, right? So, whenever a mass is applied in reactant and product, so it should be equal in the reactant and equal in the product, okay? Or any amounts of reactants should be equal in the amounts of the product. So, safe to say that we are in the steady state uh, scenario, or we are in the steady state situation or scenario, right? Or chemical reaction, steady state chemical reaction. Okay, so we are now establishing in the equilibrium, chemical equilibrium. So it should be the rate of the reaction of the reactant should always equal to the rate of the reaction of the product. Or in short, the mass of the reactant should always be equal to the mass of the product. Okay, so going back to the basic theory that mass can neither be created nor destroyed by ordinary chemical means. Okay, that's the law of conservation of mass. The same as with energy. Law of conservation of energy, that energy can neither be created nor can be destroyed by ordinary chemical means. Something like that. So it should have a chemical reactions. Okay, like that. So, say for example, in combustion of the very simple hydrocarbon, methane, CH4, okay? So it will undergo the chemical reaction process of combustion. So this will be our example of our stoichiometry. Then if there is a given mass of the reactant, or if there are given masses of the reactants, so you can compute now the masses of the products or vice versa through mole to mole ratio, mass to mass ratio with its corresponding ratio to the molecular weight, atomic weight. For example, hydrogen, 1 mole of hydrogen is equals to 2.016 grams hydrogen. So that relation or conversion factor will be used now in the chemical reactions, okay, in the stoichiometry. Okay, for example, CO2. Okay, 1 mole of CO2 is equals to 44 grams of CO2. So automatically will be their molecular molecular weight of carbon dioxide. 1 mole of carbon dioxide is equals to 44 grams, like that. 1 mole of hydrogen gas is equals to 2.06 grams. So the atomic weight or the molecular weight matters the most, something like that in the calculations. Okay, that is all about stoichiometry, calculations of the amounts of reactants and calculations of the amounts of the products, okay, in a steady state equilibrium, okay, like that. So I'll give you an example. okay, for the combustion of methane. Okay, guys, I have methane, CH4, plus oxygen gas. Okay, methane plus oxygen gas. So this is a combustion reaction because it's added oxygen or rapid oxidation. Okay, so this is combustion. Okay, from a hydrocarbon known as methane. So the product will be always carbon dioxide and water. For any combustion processes, the products are always carbon dioxide and water. And remember, in every combustion reaction, oxygen gas is added into it in an exothermic reaction, or there must be a heat applied to the system for that combustion reaction, because all combustion reaction undergoing an exothermic reaction in which heat are being applied. Okay, so our product will be carbon dioxide plus water. Okay, in order we have our chemical calculations or stoichiometry principle. Okay, we need to balance the equation first. Okay, the total number of atoms from the reactants or from the right side will be equal to the total number of atoms from the left side or the products. So you will state that individually for the carbon element, hydrogen element, and the oxygen element. Okay, let's start with carbon atoms. Carbon. So there is one carbon atom in the reactant, and there is also one carbon atom in the product. So 1 1. Okay, now you can choose between hydrogen and oxygen, which is more easy. You will start with, you will choose it. Okay, for example, we will choose hydrogen first rather than oxygen. It's up to you because it will be balanced. Okay, according to its proportion. It doesn't matter, as you will choose the easier one, it will still be balanced. In this case, we need to go for hydrogen first if we want to. Hydrogen 4, hydrogen 2, so hydrogen 4 in the reactant here. Since that is 4, so we have only 2 hydrogen in the product, then we have to multiply this by 2. Okay, so 2 times 2 of hydrogen from the product is equals to 4, so that it will be equal in the equilibrium or steady state reaction. Okay, 4 atoms of hydrogen is equals to 4 atoms of hydrogen, both in the reactant the product, it is equal. Okay, and then the last will be oxygen. 2 see. Now for the oxygen, in the right side we have 2, and in the right side we have 2, or in the reactant we have 2, and in product we have 4. So in order to compensate the loss of 2 atoms in the reactant, we need to add 2. So add 2, therefore 2 times 2 of the oxygen in the reactant. So like this, methane plus 2 moles of oxygen gas equals to carbon dioxide plus 2 moles of water. Okay, like that. So it should now balance. Carbon, hydrogen 1 from the right to the left, 1 also. Oxygen is 4 from the right and left, 4 also. And hydrogen 4 from the right and 4 also from the left. Reactants and products have the same number of atoms in each element. So the total number of atoms in the reactants is always equal to the total number of atoms from the product. So this equation is now balanced. Okay, so you should balance the equation first before we can have the stoichiometry calculations or the chemical calculations in a problem solving. Okay, thank you so much for listening. This is the introduction of stoichiometry. Thank you so much for listening and taking your time in watching this quick vlogging. Thank you so much. This is again, I am a singer, Eternal Voice. Okay, just like, comment, and subscribe, and click the notification bell for some new updates.